So I'm going to talk tonight about what is Data Hut, why did we build it, give you a tour of the site, I go behind the scenes and show you our data pipeline, talk about a few interesting results that we've seen by analyzing these projects, and finally give you some ideas we have for the future. Okay, so what is Data Hut? So this is a side project. My wife and I have a consulting company, Benedette LLC. And so this is a side project out of that. It's a directory of open source projects of things like TensorFlow or PiTorch or Redis or Pandas. So kind of all kinds of projects like that. And we're trying to focus on depth rather than breadth. So these are, we have like 124 projects right now, and maybe we'll get up to 200. I don't know, but you can find kind of sites that crawl thousands and thousands of open source projects on the web, but they're not going to give you a lot of insight into the projects. So what we try to do is combine kind of human curation and automation. So the human curation is we hand select the projects, we hand categorize them. We've come up with the categories and try to figure out what they fit into. We write descriptions for the projects and the categories. We research, who's behind the project, who were the original developers, who's, sponsoring it or whatever, that kind of thing. And then there's an automated component. We generated automated analytics, mostly from the Git commits, also from some other sources. So we can generate analytics and charts from that. And then finally, we kind of put it all together with kind of a site generator. Okay, so why did we build this? So kind of in our consulting business, we get asked a lot to advise our clients on technology choices. So it might be, I'm trying to start some project. What is the best thing should I use for this? And, is there open source that'll help solve my problem? And so some questions that we typically get asked even before we get to evaluating technologies are, what are the open source projects for solving a given problem? Are they actively developed? Are they likely to be actively developed in the future? As an example, I was asked by one of my clients just the other week about, he was interested in graphs on top of HBase. So HBase is a kind of a Hadoop-based key value store. And he was interested in, are there any graph technologies on top of it? Luckily, I happened to cover that. And we found a few, but it sounds like they haven't been touched for like 5 years. So they may not be the best option. Or they may decide, it's worth, reviving that project. Other questions, what are the licenses? Are they compatible with the way they want to use them? And who are behind the projects? So that comes up a lot as well. Another kind of reason for building this site is that we want to do market research and keep up to date on what's happening in the different open source communities, and kind of by putting together this site, this really forces us to do that. So that's another reason. And the goal is that long term, this is maybe 1 day a month or so that we'll spend on this, other than when we're maybe developing new features. And finally, this is publicity for our consulting business. So people will hopefully find out about our consulting business and maybe hire us to build their data pipeline or advise them on technologies. And at least they kind of know that we know something about these topics. Okay, so I'll go through a quick site tour, give you a sense of the site. This is a screenshot from the landing page. You can see here a few things I'll point out. So like I mentioned, we categorize projects. We have a 2-level hierarchy. So the top level has 4 categories: big data, data science, data stores, and graph analytics. So these are pretty self-explanatory. Data stores are things like key value databases like Redis, as well as like time series databases, data warehouses. So there's a number of different subcategories in that. So the subcategory level, the second level, then will be more specialized. And like an example of data science, you have deep learning, general machine learning, nearest neighbors, algorithms, about 4 subcategories in data science. And a given category may show up in more than a subcategory may show up under more than one category, and a project may show up in more than one category as well. So it's really like a directed graph rather than a strict hierarchy. We also have what we call project communities. For every project, we track kind of who are the backers of the project, and either financially or providing organizational support. And so we track that information. And for some of the bigger communities, we have kind of analytics just on those communities. So those are like Apache, NumFocus, which has a bunch of data science projects, as well as some of the companies like Google and Facebook, which obviously have lots and lots of open source projects. Finally, we have project news. So we're tracking for every project, kind of when they have major releases. We try to include that in our database. And so the releases that happen in the last couple of months show up on our homepage. Finally, there's a couple other ways you can navigate. So the project list page shows you all the projects that listed alphabetically with their icons, if you like that. And we also have a search box, so you can search the site as well. Talk a little bit about a few of our visualizations. So one of the more interesting things was we built a bunch of analytics. How do we present this information to people so that they can get an intuition of the data? And to me, this is kind of one of the more interesting problems in data science. And so this particular visualization that we came up with is showing you all the data science projects within this. So this is the top level category. And what you can see is there's something like 60 projects. The x-axis is based on sort of the metrics that are the absolute size of the project. And the y-axis are things that is kind of like the growth of the project relative to its current size. So that's basically a trend for the project. So if you combine these together, in the upper right-hand corner, these are the fastest growing big projects. And the lower left-hand corner, these are the slow growing smaller projects. And this line here is kind of a trend line combining all these together. So you can see what the general trend is. Obviously, in this particular case, they don't fit the line very closely, but it kind of gives you a sense of where things are. And things above the line tend to be growing fast for their size, and below the line are growing slower for their size. And the way we come up with these scores is we take individual metrics. So like for size, we might look at the total commits over the lifetime of the project. And then we will take it for all of our 124 projects and put them into 10 bins. So that the highest bin, the bin number 10, is the top 10% of the projects, and bin number 1 is the bottom 10%. And so we do this across the metrics in that we're looking at, and then we average those scores, and that's how we come up with the scores. So here's another thing. We have this kind of chart on the kind of leaf project level. So this is looking at a more specialized set of projects, and it's just to give you a different view, and it's more concrete in the sense that we have the age of years and x-axis and total lines committed on the y-axis. And the size of these circles is representing kind of how many commits happened the last year. So you can kind of see, like, for example, something like Cafe, it has I don't know, 10 to the 7 commits almost, but in the last year it has nothing. So that kind of tells you it's dead. And you can kind of see here, like TensorFlow is way up here, and so is PiTorch. This is a project page, and so we have a bunch of data about the project you can look at. I think one of the things that kind of took a little experimentation is coming up with this chart here. It's showing you the total lines committed over the history of the project, and at the monthly, so it's total monthly lines committed. And then we take a 12-month rolling average, so that smooths out the graph a little bit. And I think it gives you, if you want to see at a glance kind of what is the trend for the project, this kind of gives you a sense of what that activity is. Talking a little bit about implementation. So this is a completely static site. We pre-generate all the pages and all the visualizations, and we run it on Cloudflare. So we're using Cloudflare as some new feature called Pages, which you can basically do a git commit, push something, and then it shows up, and they're basically hosting the website then. And then they're also providing the content delivery network. And so it's really fast, which I think is an important, if you want this. People, there's no trackers or anything. So the only kind of, analytics we're really getting from the website itself are kind of aggregate statistics, because we kind of really believe in, not invading your privacy. So all the analytics and site generation are heavily using open source technologies. We kind of dump all of our data once we've kind of organized it into a graph database. We use pandas, obviously, for data manipulation. Jupyter is where we run these pandas analytics. Matplotlib for the charts. Data Workspaces is a project that I'm co-founder of, that's for tracking experiments and data lineage. Sphinx is for page generation, which might be kind of surprising. You might think of it as more of a tool for documentation, but it's actually really great for static websites. And if you're interested in that and everything, there was a talk at PyCon by Paul Everett about using Sphinx for static websites. But in general, it took us a little bit to come to that, and we're really happy with it. And I'm using SnakeMake for workflow automation. This is what our data pipeline looks like, and kind of real quickly, you can see we're downloading from a Git hosting service, which will be unnamed. Eventually, we want to support multiple of those, but the idea is we download the raw commit data, and it comes to us as JSON data. So we save all the raw files as compressed JSON files. I think we have over 1 million of them now. And then from there, we do some post-processing to give us a compressed CSV file that's all flattened up and easy for pandas. I'm sure Matt will tell you how you can process that file once you have it in CSV format. So then we have our Jupyter notebook. And kind of in parallel, we do kind of all of our hand curation in Google Docs, mostly in spreadsheets. And then we can download the CSV and check it into Git. And from there, we do processing, and we build this graph database, combine it with the analytics. And then we have some scripts for page generation to give us our website source, which is like restructured text and images. And then Sphinx will combine everything together. So anyway, it's pretty much, other than kind of putting in the hand generation stuff, it's pretty much automated. And the other thing that's not automated yet is kind of the placement of labels on the charts. Sometimes I have to tweak those a little bit. Anyway, if anyone knows how to do that, I'd love to hear a better approach. Some interesting results. I was kind of surprised that this project, like if you look at this chart, that you see the line going up. I would expect it to be going down, that smaller projects would be growing faster. But I think this is more of like you see a winner takes all trend, where a lot of projects, they get a lot big backing, whether it's something, like say TensorFlow or PiTorch or CatBoost, which is being backed by a big search engine. And so a lot of these projects backed by big companies or have large communities attached to them, even though they're big, they're still growing very quickly. And obviously at some point, some of these projects may fall out of favor and they may kind of fall down below the line here. The other thing is VC funded startups tend to show the fastest growth. So if you look up here, Hugging Face, Transformers, and Ray are both VC funded startups. So they've been able to hire a lot of full-time developers to work on their code bases and have a big marketing effort. So those seem to be the biggest. You may have heard a lot of things about, AGPL and weird licenses that companies are coming up with to prevent hosting by Amazon. But most of these projects are still using permissive licenses. So the trend is not as big as you might hear from the noise on the web. And data science is a more dynamic space right now than big data. Big data has been around longer, it's more mature. Deep learning certainly has some really large and active projects, and there's also a lot of niche projects, smaller projects in data science as well. Future plans, we're looking at maybe adding links to learning resources, trying to figure out what are the best tutorials and things for different projects, so you don't have to kind of go through a bunch to try to figure out what are the best. Link to some of those, maybe create some of our own content, those kinds of things. And also looking at exploring the relationships between projects based on, and contributors, things like that. Ideally, I'd like to have like a page rank for projects where we use their ecosystems to say which projects are the most influential. So anyway, that's it. Thanks a lot for your time. I'm happy to answer any questions. You can see I have we have slides online. You can email me, Twitter, LinkedIn. We'd love to have your feedback on the site, what you'd like to see on it.